Welcome to Structure Companion. This YouTube channel is where you will find most of the concepts of structural engineering and civil engineering being taught in a practical manner. I would like to invite you to subscribe, like, and comment these videos so that many people can get access to this content. Our today's topic will be the continuation of our previous topic regarding loads. In our previous session, we talked about point load, UDL, and UVL. Now today we'll be trying to show the process of determining a UDL. Like when we have a UDL which is applied on a beam, how we calculate the UDL and apply it on the beam. So in today's session, we'll be calculating the UDL applied on a particular beam. So for our problems today, it will be at the end of this session, you should be able to determine the load that to understand the procedure of determining the loads that are coming to a beam, to determine them, calculate them. Okay, let's get started. Our first our problem will be focusing on this beam here, this particular beam here. This particular beam is where we'll be focusing today. Okay, so the problem is about a bridge. This is a bridge, okay, and on this bridge here we'll be focusing only in this particular part of the bridge. To be not a complete bridge, only this particular part of the bridge, and we say it is 80 meters long. It is simply supported. As you can see, it is not continuous, simply supported. Here is 0, here it's 80 meters long. Like the length is 80 meters, and it is pinned here, roller supported here. If we cut a section through this beam like this, okay, if we cut, don't focus on this, don't focus on the dimension given here. We'll be dealing with 80 meters. For us it is 80 meters. No need to focus on that. So if we cut a section anywhere in this length, let's say we cut a section here. Cutting a section means it is as if we are standing here and trying to look in this direction. Okay, if we come and stand here and look in this direction, this is what we will see. This is what we will see. This is the section of this bridge. Okay, this bridge here is made of concrete. This is the slab of the bridge, or the deck we call it, and this is the beam of the bridge on which the bridge is supported. So if you can see, these beams here are drawn here. This is the beams here. It is in the longitudinal direction, and this is when we cut a section, this is what we find. Now after getting this is your beam, the beam we will be studying today, and this is the slab. So today we have to determine, so the main purpose today is to determine the load, the dead load only that is coming on this particular beam. It will be to determine, our main purpose is to determine the load. Okay, to determine the load. Now let's get started. The first step to do is, when you are trying to determine the load on this bridge here, notice this beam here is taking part of the load, okay, and this beam here is taking also part of the load. This one also is taking part of the load, but we have to determine how much portion of the load is coming on this particular beam here and how much is coming on this particular beam here. So What we'll do mostly is to divide the length between these two beams into two. So it means here it is 60 meter. It means if I divide the length here into two like this, okay, let's say divide here, it means here it is 3 meter, and then I go to the half portion of this one also, okay, it means this is 3 meter. If I cut from here, this is 3 meter, 3 meter, and here also this is 3 meter. Okay, so it means the portion of the slab which is resting on this beam here is 6 meter. 6 meter. Now, it is given that the slab has thickness of 250 millimeter, and the size of this beam is the same as this one and this one. So it has the depth of 300 millimeter, 300 millimeter, and a width of 200 millimeter. It is the same. So first we have to determine the loads coming from the slab. I'll just do like this. I'll first determine the loads coming from the slab in green here. This would have to determine how much it is. Loads coming from the slab. Okay, I'll write it here. I'll write it here. Slab load. Okay. For the slab load here, notice that the unit weight of concrete weight or unit weight is equal to 24 kilonewton per meter. Okay, so I will first determine what is the area of this section. Remember, this is 250 meter, so the area of this slab, the area of this portion here, I have to determine first. Okay, so area is equal to 250. This is the thickness. This thickness here is how much? In meter, it is 0.25 meter. I have to multiply it into the total length here, the length, which is the length of the beam resting on this beam, is 6 meter. So I take here 6 meter. So it will be 0.25 into 6 is equal to 1.5 meter square. This is the area of this slab. Okay, so if this is the area of the slab, I need to take also the area of determine now the area of this particular beam. I have to determine the area of this beam here. If I determine the area of this beam, I have to write here, I just write here the area of the beam. I'll take blue color. Okay, I'll take the pink one. I'll now determine this area, the area of the beam. Now, beam, I'll write here the beam area. This beam area here, beam load, I have to say, not beam area. Beam, well, let's say beam area. Beam area is, we know it was area is equal to 0.2 meter. It is the width here, 200 millimeter becomes 0.2 meter times the depth, 0.3 meter. Remember that the dimension of this beam are the same as this one. So the area is equal to is equal to 0.06 meter square. So the total area, we'll calculate it in black. I'll put it in black. Okay, total area is equal to 1.5 meter square plus 0.06 meter square. It gives 1.56 meter square. Okay, so this is the total area. Now to determine how much load is coming, because they say the unit weight of concrete for each meter. If I have 1 meter of a slab made of concrete, remember that the beam and the slab both are made of concrete. It was 24 kilonewton per meter cube. I forgot. Sorry. So 24 kilonewton per meter cube is the unit weight of the concrete. So I need to determine, because remember it is a uniformly distributed load, because this load here is continuous. It is the same load throughout the length. So this is what we have to determine here. So I just plot here this beam. Okay, it is this beam here I'm plotting here. It was simply supported everywhere. Simply supported. Okay. Hinge support, roller support, and here we have our UDL, the one we have to determine. This UDL here, because we know it is distributed. It is the loads coming from this slab and beam. Here we need to apply it on this beam. This beam here represents this one. This beam is continuous, so it is representing this beam here. So how much UDL will be having on this beam? It will depend on the area. With this area, I have the UDL will be, because UDL always is in kilonewton per meter. If I multiply this area and the unit weight of concrete, then it will give me the UDL which is applied on each meter of this beam here, which is the central beam of this slab. Okay, so to get the UDL here, it will be the area. The total area is 1.56 times, okay, I will write here meter square, times 24 kilonewtons per meter cube. Okay, I just make it clean here. Which is equals to it is equals to 37.44 kilonewtons per meter. This is our answer. This is the UDL we have been trying to calculate to determine how much UDL. This UDL here once again, this UDL or this UDL here is applied on this beam here. For the total length of this beam, we have 37.74 on each meter. So I'll write it here correctly. 37.44 kilonewtons per meter. So from here you can calculate now the reaction and everything, and bending moment and shear force, so that you can try to determine what is the size of the beam required, so that it sustain the load. Okay, hope you enjoyed our today's session. And I will invite you, if you are a civil engineer, a student in civil engineering, I will invite you to share this channel with all your friends, so that they can access to the content as well. And let's make the channel known to everyone, so that we can enjoy. If you have a question, you can put it in the comment zone. It will be my pleasure to respond to your question. Thank you, and don't forget to subscribe and like the video. Thank you. Let's meet to our next session. Bye bye.